Thank you all for coming today. I know it's very busy. Welcome. My name is Myron E. Bell. I work at the Competitive Enterprise Institute. I'd first like to thank Chairman Lamar Smith and the Science Committee for providing this room for our event today. The Cooler Heads Coalition has been around since before the Kyoto Protocol was negotiated in December of 1997. Starting in 1998, the coalition has held a number of briefings on Capitol Hill with some of the leading scientists, economists, and other experts on climate science and climate policy. We have two other outreach efforts. One is the Cooler Heads Digest, and there are copies out on the table outside. You can subscribe to it at our other main outreach, which is globalwarming.org, which is edited by my colleague William Yateman, who's here today. And globalwarming.org has lots of good stuff on it, and I encourage you to go to it and then sign up for the Cooler Heads Digest. Before I introduce David Archibald, I want to mention the Heritage Foundation and another member of the Cooler Heads Coalition, the Heartland Institute, are having a briefing on their massive non-governmental international panel on climate change report, which is an alternative to the UN IPCC report. That briefing is next Monday at 12 noon at the Heritage Foundation, and you can sign up for it on the Heritage Foundation website. The same people who are giving that rather long briefing will be over here in this room at something like 3 or 4 p.m. We haven't settled on a time yet, to give a 1-hour version of that. So if you can't make it to the Heritage Foundation at noon next Monday, you can come here and get a somewhat condensed version of that report. And another Australian will be one of the chief briefers at that briefing, Bob Carter, another good friend of ours from up in Queensland. But today we are lucky to have David Archibald here from Perth, Australia. He, from his bio, which I think you've all read on our invitation, is involved in a lot of things, and he's a very clever man. He's been very interested in solar cycles for a number of years, and he's written a book on it. You can find his frequent blogs on the site What's Up With That, generally. He's here in Washington right now because he's also a lecturer at the Institute for World Politics, and he's giving some lectures in the next week or two. And so we're lucky to have him here today. I'd just like to say, just to frame what David is going to say, the climate science establishment represented at the UN Intergovernmental Panel on Climate Change has always minimized all other factors besides the human imprint of carbon dioxide. And they now have a problem because they have minimized things like solar cycles for the last 2 decades, and now they are having to explain why we haven't had any warming for the past 16 years. Now, the reason might be in some of the things that David is going to talk about today. I don't know. I don't think anybody knows, but there is a lot of evidence that there are many things that drive climate variability besides human-produced carbon dioxide emissions. And David has, I think, an outstanding presentation. He's going to talk about solar cycles, and he's also going to talk about what he thinks may be the result of this period of solar cycles, which is a period of stress that is, I suppose, similar to the stress claimed by the global warming alarmists. Maybe we could call you a global cooling alarmist, David. But with that, let me please welcome me in joining I can't talk anymore. Please join me in welcoming David Archibald. Thank you.
Thank you, Myron. Do we live in a special time in which the laws of physics and nature are suspended? No, we don't. Can we expect relationships we see between solar activity and the Earth's climate going back 300 years and more to continue for at least another 20 years. As President Obama used to say, and this is some time ago now, yes, we can. Today, I will tell you a story about climate that is different from most in the public domain. It is a story of continuing cooling. And to put that story into context, we'll be asking ourselves these 5 questions, starting with, has the world warmed? Well, a good place to start is global sea ice extent. And as you can see, this is from when the satellites went up in '79, that there's been no net change over the last 34 years in global sea ice extent. If we go to the temperature record, once again, the satellites went up in '79, we are slightly above that 30-year trend. And we're actually just about where we were back in 1983, 30 years ago. If we go on to the southern hemisphere, where I come from, we've actually had an increase in Antarctic sea ice extent over 30 years, suggesting that the planet is cooling. If we go now back 60 years, this is Alaskan temperature data from 1949. And what we see is 30 years of cooler climate, the Great Pacific Climate Shift in 1976, and then we had 30 years of warmer temperatures. And this is driven by something called the Pacific Decadal Oscillation, which is usually about 30 years long. So we're probably heading for another 30 years of cooler climate in Alaska from here. Let's look at the United States state high temperature records back to about 1890, when high-quality temperature records started to be made in the United States. The bulk of US state high-temperature records are set in the 1930s, over 80 years ago. And if we look at this record back to 1910, of the number of days that weather stations in the United States recorded temperatures over 100 degrees, once again, the peak was back in the 1930s, and the incidence has declined thereafter. Another place to look for warming is in Northern Hemisphere snow cover for winter. And this is from the first satellites that went up in '67 and took photographs. We had the 1970s cooling period in here when there's a lot of snow, but actually the last 4 years have exceeded that, and the snow cover has increased. Now, has warming occurred in the past? The thermometer was invented back in the 17th century, and they started taking records of what the temperature did on a daily basis. This is the longest thermometer record on the planet, which is the Central England temperature record from 1659. There are a couple of things to see in this record. You've got these periods, the Dalton minimum and the Maunder minimum, where we had some cooling associated with low solar activity. But it also draw your attention to this rise in temperature from 1695, an average temperature of 7.25 degrees over the year. That was a rise of 2.2 degrees in about 40 years, and that rise was 3 times as large and twice as fast as the total rise of the 20th century that has got some people hot and bothered. I'd also point here right now where I think the temperature is going to be over the next couple of solar cycles. We're currently in solar cycle 24, and this is a prediction for solar cycle 25, within the range of the instrument record. Now let's go back 2,000 years now. That's where we are in the modern warm period, but it's not much different from the previous 2 warm periods in the last 2,000 years, the medieval warm period and the Roman warm period. We go back 12,000 years, and temperature was actually higher 6,000 to 8,000 years ago in the climate optimum here, and sea level is about 2 metres higher. And temperature since then has been falling by 0.25 a degree centigrade per 1,000 years. Now, when I asked at the beginning of this presentation if we lived in a special time, well, that is true of the last 3 million years, because 3 million years ago we entered an ice age that possibly has up to another 30 million years to run. And what we see here is the Vostok ice core record from the Antarctic plateau, about 450,000 years of data. We're in a period here called the Holocene, and the previous interglacial was called the Eemian. These occur about every 100,000 years. Our interglacial, the Holocene's already lasted 12,000 years. It's been quite a long one. Now, I put this graph together to try to get an appreciation of how fast we might enter the next glacial period. And what I've done is get the last 5 interglacials and align them on the peak temperature. And this bit here I've blown up over there, and the purple's the Holocene and the yellow's the Eemian. Now, if the Holocene ends up anything like the Eemian, we've got another 3,000 years of little ice age conditions. If it isn't, well then we'll just keep plunging away into the next full-blown glaciation. Now, Alan was asking me about the solar cycles earlier before this meeting. And this is a graph produced by an anonymous academic who wasn't a name associated with it, but it's quite accurate. This is a calculation of the future interglacials and glacials based on orbital parameters. That's the hindcast match, which is very good, which gives us a lot of confidence about what it's predicting. And it says that we're about here now and will be full-blown glaciation in 55,000 years. Now we'll spend a bit of time on this question. Is warming linked to carbon dioxide? It's an important question to ask. Now the greenhouse gases keep the temperature of the planet 30 degrees higher than it would otherwise be if they weren't in the atmosphere. So the average temperature of the planet is 15 degrees centigrade. If they weren't there, it would be minus 15 degrees centigrade. 80% of that effect is provided by water vapour, 10% by carbon dioxide, and methane, ozone and so on make up the rest. So carbon dioxide is worth about 3 degrees centigrade. The pre-industrial level of carbon dioxide in the atmosphere was about 280 parts per million. Let's round that up to 300. You could be forgiven for thinking that the warming relationship between carbon dioxide and temperature was about 1 degree centigrade per 100 ppm. We're currently putting into the atmosphere 2 ppm per annum. So that's 100 ppm every 50 years. If that relationship was true, we'd be adding 2 degrees centigrade per century and we would fry. But the relationship isn't arithmetic, it's logarithmic. And fortunately, the University of Chicago maintains a website called ModTran, which enables you to plug in an assumed carbon dioxide concentration in the atmosphere, and it'll tell you how much heating it produces. So I did that in 20 parts per million increments, what you see down the bottom here. Lo and behold, the first 20 ppm is worth half the heating effect to date. And then it drops away rapidly, such that at the current level we're at here in 2013 of 400 ppm, every 100 ppm extra only heats the atmosphere by 0.1 of a degree centigrade. Now what I find amusing about this whole global warming debate is that in the glacial periods, the carbon dioxide level of the atmosphere fell down to 180 ppm at its lowest. Plant growth shuts down at 150 parts per million. Several times in the last 3 million years, life above sea level almost died out due to a lack of carbon dioxide. We were only 30 ppm from extinction, several times. Surely, the higher we can raise the CO2 concentration of the atmosphere, the safer life on this planet will be. Now what I've done in this graph is show what the data on the previous graph in one bar. So that's the first 20 ppm, half the heating effect to date. The pre-industrial level, we've probably added about 0.1 of a degree to the temperature of the planet, or the atmosphere, in the last 150 years. And if we dig up all the rocks we can economically burn them, we might get to 600 ppm, another 0.3 of a degree centigrade. And that is lost in the noise of the climate system. Now, I put this graph together to try to show what belief in what the warmers believe requires. So we get the data from the slide 2 slides ago. Instead of making single, we just make it cumulative as you rise in ppm, and we flatten out here, nothing happens. But to believe in global warming, which some of them say there'll be a 6 degrees centigrade rise by the end of this century, we'd already have to have seen 2 degrees centigrade already. We don't see that. But the other crazy thing about this belief system is that their warming starts exactly at the pre-industrial level. It doesn't start over here or over there. It's exactly at the pre-industrial level. It's a rather strange thing to want to believe. This is where carbon dioxide's coming from in terms of coal production and consumption. This is, the United States is the bulk of this, about 1 billion tonnes per annum. What happened in Europe after the fall of communism, their coal production fell away rapidly. The opposite thing happened in China. They're doing 4 billion tonnes a year, about 4 times what the US is doing. And this is my perception of where carbon dioxide is going to come from in the atmosphere. This is a 500-year slice from 1800 to 2300 by oil, coal and natural gas. And we use the outline of that graph in this graph, showing the carbon dioxide production and the Mauna Loa CO2 concentration history. You see a couple of interesting things here. The Mount Pinatubo cooling resulted in the oceans cooling and sucking down some carbon dioxide. Similarly, this is the 1998 El Nino. We've got 20 or 30 years to go to a peak CO2 production in the atmosphere, and that'll fall away. Now, the global warmers say that even if the temperature of the atmosphere isn't going up, the oceans are acidifying, and all the fish and all the other slimy things in the sea will die. Well, to put that claim into perspective, this is a coral reef on the Dobu Island in New Guinea. And these white bubbles here are streams of pure carbon dioxide. That's live coral here, and those are fish swimming around the background. This lagoon has a pH of 7.3. 7's neutral. Anything above 7 is basic. The open ocean is 8.1. So there's what's supposedly highly vulnerable marine species living quite happily in the most extreme CO2 environment you could hope to create. Now, let's go on to what's really happening, which is that the sun drives climate. What this graph shows is the solar activity as expressed in solar cycle amplitude back to 1749 when solar cycles started being numbered. And from the left, there's a period here, that's solar cycle 1, that's 4, that's 5 and 6. We had a period of cooling here during the Dalton minimum associated with these weak 2 solar cycles. That's when the Thames froze over last in 1816 in central London. Little ice age ended here in 1900. Then we had very strong solar activity. We're just about here now at the peak of solar cycle 24. And all the astrophysicists in the world have only produced one forecast of the amplitude of solar cycle 25 yet, and that's Livingston and Penn of the National Solar Observatory, who've made a forecast of 7, which will be the weakest solar cycle for over 300 years. What this graph shows is the last 8,000 years of solar activity by these researchers, Steinhilber and Beer, 2013. And they've come to the conclusion, they produced this graph showing that the sun was more active in the second half of the 20th century than it had been in the previous 8,500 years. Now, all the energy that stops the Earth from looking like Pluto comes from the sun. So you might expect that if there's some variation in solar activity, there will be an effect on climate. But the major effect isn't directly related to amplitude. There is a correlation between solar cycle amplitude and temperature over that solar cycle. But 2 Danish researchers back in 1991, Friis Christensen and Lassen, found that there was a stronger correlation between length of a solar cycle and temperature over the following solar cycle. And in 1996, two researchers at the Amar Observatory in Northern Ireland decided to apply that theory, Fritz-Christensen and Lassen theory, to the 300 years of Amar temperature data. And this is figure 5 from their 1996 paper. What you see on the x-axis is solar cycle length increasing to the right, and temperature at Amar increasing up the y-axis. And on their original figure here, with these dots and the line of best fit, there's not much scatter about that line of best fit. So when I saw this, I said, this is a very good prediction tool. If you have an estimate of solar cycle length, you can predict climate over the next solar cycle. So on top of their graph, I plotted up solar cycle 22, which was 9.6 years long, ended in May 1996. Solar cycle 23, which was 12.5 years long, ended December 2008. And based on this established relationship, Amar in Northern Ireland will be 1.4 degrees colder over this solar cycle than it had been over the previous solar cycle. And of course, you can apply it to just about any other long temperature record on the planet. This is Hanover, New Hampshire. And this is a good proxy for what's going to happen along the US-Canadian border in terms of latitude and for the Corn Belt. Hanover, New Hampshire's got a steeper relationship. It's 0.73 degrees per year of a solar cycle length. And Hanover's heading for a 2 degree centigrade decline over this solar cycle on average. Now, I was on my lonesome with this for a couple of years, but fortunately about 3 years ago, a Professor Jan Erik Solheim, who's an astrophysicist at Oslo University, found my stuff on the net, decided to apply it to the Norwegian temperature record, and he produced this map in a magazine article in Norway, showing for about 12 Norwegian temperature records the relationship between solar cycle length and temperature. And here I've got Bergen on the west coast and blown it up. And Bergen's headed for a 1.5 degree temperature decline, much the same as Amar in Northern Ireland. And in 2012, they published this paper crediting me with the discovery of this methodology, which enables near-term climate to be predicted with great accuracy. And in that paper, they made a prediction for the Northern Hemisphere, which is the same as the whole world. And they're predicting a temperature decline of 0.9 degrees centigrade over this solar cycle, which will take us back to temperatures of the mid-19th century. And they go on. It's easy to do this stuff. It's basically high school level mathematics to make these predictions of a good quality temperature record. This is Donbass in Norway, going for 1.5 degree centigrade decline. And this is Svalbard, which is an island up near the Arctic Circle, which temperature in winter will decline by 6 degrees centigrade. And then basically that's the polar amplification effect. Now we can go beyond solar cycle 24 because 2 years ago, another researcher at the National Solar Observatory, Dr. Richard Altrock, published this graph, and I've annotated over the top of it, of green corona emissions of the sun. And what you see here are the various solar cycles. That's 23, 22, 21. That's solar cycle 24 up to about 2 years ago. He hasn't published this diagram again since, but in his April 2011 paper, he said that solar cycle 24 was about 40% slower than the average of the previous 2 cycles. So we can estimate how long it's going to be. It's going to be 17 years long and end in 2025. That's about 3.5 years longer than solar cycle 23, which will make the world colder again if the relationship holds in a linear fashion. Which means we can take a climate prediction out to 2040. Now, taking these 3 tools I've just told you about, solar activity forecast provided by Richard Altrock, the solar cycle length temperature relationship, and the logarithmic heating effect of carbon dioxide, We can combine those things to make a prediction for Hanover, New Hampshire out to 2040. The blue line includes the carbon dioxide heating effect, and the red line is the pure solar effect. And 24 should take us back to the mid-19th century, and 25 will take us back to temperatures last seen in the Maunder minimum in the 17th century. We have seen these sort of temperatures before. This is the Central England temperature record again, the Dalton minimum. And this is a spike down in the last decade of the 17th century, 1690 to 1700. And that killed off a third of the population of Finland. In terms of more detail on a monthly basis, the sun is tracking solar cycle 5, the first half of the Dalton minimum. That's where we are in September 2013. And the temperature decline of the Central England temperature record is in line with my prediction. It's fallen about 1 degree centigrade so far, this in the last 10 years. One thing I'm proud of is help some other researchers get their work published. There's an electrical engineer in Ohio by the name of Ed Fix who contacted me by email. He sent me a model he'd created. What you see here in the green is the solar cycle record, and he simply inverted each second solar cycle. And this up and down business reminded him of the ideal spring relationship in engineering. So then he downloaded the NASA planetary orbital data and made up a model, and his hindcast match is very good, which gives us a lot of confidence about what his model's predicting. And it's predicting very weak solar activity in the next 30 years and then a return to more normal conditions mid-century. Other people have predicted weak solar activity. And basically, for the next few slides, I'll be showing some other people who've made forecasts of cooling. I'm not the only lonely one in that. This is Clovelard back in 2003 predicted solar cycle 24 was going to be very weak. And you expect the climate to be colder associated with that. And solar activity does drive sea level. This is data from Simon Holgate, the National Oceanographic Centre, England, from 1909 to 1999. And there is a broad sort of match between solar cycles in red and sea level in blue. That's a rate of rise of sea level in millimetres per annum. But there's a very good match here between 1948 and 1987, when solar activity was rising very strongly. And from that, when we plot it up in this XY graph, it shows a relationship of 0.045 millimetres of rise per one sunspot number. And the breakover point is 40, a sunspot number of 40, which equates to an F10.7 flux of 102. Below that level, sea level falls, and above it, it rises. Now let's use that relationship, apply it to the solar amplitude record back to 1646, and this is theoretically what we should have seen. We do see a very steep rise here from 1934, should have peaked in 2003, and the projection is it'll start falling again from here. Now, what's the official sea level rise data showing? This is from the University of Colorado. They have the satellite data and they plot it up. And they get this relentless, remorseless, unremitting rise of sea level of 3 millimetres per annum, which equates to, I think is it 2 inches every 10 years or something. It's enormous. But how they created that, this graph from a paper in 2008 shows the raw data they get from the satellite feed, and they make an adjustment to it. And the adjustment is a notion they dreamt up of isostatic rebound of the continents from the ice sheet. And of course they need to do this to keep their jobs. But as opposed to the real data, this is from an island in Sydney Harbour, Fort Denison, from 1915 out to wherever it is, 2009. And it's been 0.5 millimetre per annum, not 3 millimetres per annum. That's about 2 inches per century. Now on to some of the commercial and social impacts of the cooling that I'm projecting. Last time there was a major cooling period that got people concerned was in the 1970s, in the 1970s cooling period. And this is a map of Canada produced from a paper published back in the 1970s, showing the theoretical growing limit for wheat in this dashed line, and the heavy black line is what that would shrink to if temperature fell 1 degree centigrade. Now, that would decrease the frost-free period by 15 days and make the wheat crop a bit in jeopardy. 2 degree decrease would not allow the wheat crop to ripen before the first frost. And the sort of decrease I'm projecting, I think the Canadians will go back to trapping beavers for agriculture. Similarly, this is a paper from, I think it's 1980, of what would happen to the Corn Belt if temperature rose or fell by 1 degree centigrade. And the relationship is about 144 kilometres of movement for every 1 degree centigrade change in temperature. Now, given the temperature decline I'm projecting, the Corn Belt will shift to the Sun Belt about 500, 600 kilometres. And it's happened before in the United States. This is a map produced by archaeologists of the northern limit of Indian corn growing at the height of the medieval warm period from 1000 AD to 1250 AD, and what that shifted to during the depths of the Little Ice Age from 1350 to 1550 AD. And the biggest shift was about 300 kilometres southward. So we have seen it before in this country, and it will happen again. Now, one of my areas of research at the moment is trying to figure out what will actually happen to grain production, not just guessing, but trying to do it more scientifically. And this is a town called Whitestown, about 20 kilometres northwest of Indianapolis. And they've got good temperature data from about 1900. So what I've done here is get the growing degree days for the period 1901 to 2010, that's in blue, and the more recent decade, 2001 to 2010, in red. And modern hybrid corn crops generally take 2,500 GDDs to ripen. If you don't get the crop ripened before the first frost, then you're likely to lose all the value of it. If we revert to the temperature of 100 years ago, we'd probably have a 15% reduction in corn yield out of the corn belt. Now, back to who predicted the current cold period. Well, the first people to predict it successfully were the CEI back in 1974. And what I'd like to draw your attention to is this last sentence, because they say this is because, but during 50 of the last 60 years, the Earth has on average enjoyed the best agricultural climate since the 11th century. We, in this modern age, in the early 21st century, think that what we've experienced for the last 3 generations is normal. No, it's only abnormally good. We will revert to what agricultural conditions are like in the Broad. And that's the cover of that report. It was actually found in the London Library. The next successful prediction was Hubert Lamb, the eminent UK climatologist. The German Navy asked him to write a report to explain why sea conditions had changed in the North Sea since the Second World War. And he plotted up 600 years of wind direction data for London, and then he found there was a 200-year periodicity, so he moved the whole curve 200 years to the right and got a forecast cold period just about where we are now. But the best prediction I've come across was Libby and Pandolfi in 1979. They used tree ring data from a redwood forest in Kings Canyon in California. And they got the small detail right up to year 2000, and they produced a prediction of decline in the sort of league that I'm predicting. They said it was going to rise by 0.25 of a degree to 2000 and then come off very steeply. And this is a prediction from some Finnish forestry researchers using tree ring data to tease out the cycles and see what's going to happen. And they're predicting a major decline in temperature which will be the largest for 500 years. Now, I find it astonishing in this day and age that people can make these predictions on physical evidence and no one seems to take much notice of them because the implications are profound if they are correct. But it can get worse than what I projected so far. If we have a major solar-driven cooling period and we overprint it with a major volcanic eruption, then we get an 1816 type cooling event. And what I've put this slide up here for is to show Mount Pinatubo in the Philippines blew up in 1991, and in 1992 the temperature of the atmosphere was 0.7 of a degree colder as a result of that. The last time that happened was Mount Tambora in Indonesia, blew up in April 1815, and the temperature of the planet fell by 0.7 of a degree over the following year. But for some reason, Canada and the northern US through the Corn Belt had a much increased climatic effect from that. And the oats price rose from 12 cents up to 92 cents and so on. And these things come about every 45 years, so we've got a 50% chance of having one in the next 20 years odd. And sometimes severe cooling can come out of the blue without any warning from volcanoes or from solar activity. Once again, we return to the Central England temperature record, which is the blue line from 1715 to 1745. And you'll see this spike down here in 1740. That spike down killed 20% of the population of Ireland. And on top of that, we've got the last 22 years of data from 1990 to 2012. We get a generalised similarity between those graphs. And if climate repeats, we may be just 2 years off from a major spike down, which the world certainly wouldn't be prepared for. Now, I have some recommendations to make in climate research that someone update the Libyan Pandolfi tree ring data. It worked very well then, it's likely to work very well again. There's lots of forestry stands around the Northern Hemisphere and the Southern Hemisphere we could corroborate. Further develop the solid planetary model of Ed Fix. He's a full-time job as an electrical engineer, he can't take it any further himself. And then model what will happen to the Corn Belt and so on as these things hit. In summary, carbon dioxide's heating effect is real but minuscule. It's just lost in the noise of the climate system. And we're in the beginnings of a major solar-driven cooling event, which will be very testing. Thank you very much, ladies and gentlemen.
Thank you, David. Now we have plenty of time for questions, so please tell us who you are, and William will come over with the microphone so that we can get it on our tape here. So, who has a question?
Hi, I'm Tom Weissmuller from colderside.com. The question I have is one of prediction. Everyone, mainstream science has been predicting warming for the last 20 years, and all of a sudden now we have a temperature standstill or flat line. So now they're predicting more extreme weather events. It seems that the mantra has changed. And now we're finding out that these extreme weather events really aren't happening. We have the fewest hurricanes hitting the United States in quite a while. Tornado activity is down. So my question to you is, what do you think the next prediction is going to be from the people who are trying to drum up hysteria in the climate?
Actually, I can't think inside their heads. I can't preempt what they're plotting, actually, I'm afraid. I'm not that bizarre.
Thank you.
Randy Randall. We saw a presentation earlier this year from the Israeli Shaviv, and he said he had a paper basically back in 2008 maybe, where he kind of predicted the same effects. Have you compared any of this work with others that have looked at this effect? Shaviv, I think Akasofu did something like this.
Shaviv concentrated on total solar irradiance, and he has got a relationship I think it's 0.6 of degree centigrade per 1 watt per square metre. There's a bloke in Perth, another researcher, who's got a paper coming out next month that'll be quite significant on that effect. On Professor Agafoksu's work, I believe he's a bit of an arm waver. If you look at his graphs, they just have temperature rising in a wavy fashion without any physical basis to that. Yes, Mark.
How does it tie in with Sven's mark and cosmic rays and his whole theory? Anything you say? How does that effect play into this?
Well, we live in a wonderful world where it's very hard to tease out what's actually driving climate. There is a correlation between galactic cosmic ray flux and low-level cloud cover, but it's not strong enough to explain more than 20% of the heating effect and cooling effect that we've got. There are other things involved. That's most likely to be largely overdriven by UV affecting the jet streams.
I just want to, just real quick, a quote from Scott Mandia, a global warming activist scientist, who says, he just said this 2 days ago, quote, "Humans are responsible for more than 100% of the observed warming since 1950. Some of that has been offset by natural variability." That's the latest line now from the global warming activists. In other words, that we have basically been driving at least half of the 20th century, but that natural variations have prevented some of the warming.
Well, as I think I've demonstrated here, that carbon dioxide can't do it. It just doesn't have the oomph from here. It's all tuckered out.
On that, I'm sorry, Pat McLaren. I'm with Senator Ron Johnson. On that graph that illustrated what the warmists imagine the effect is going to be, there was that odd inflection point, of course. What would their, speaking charitably, what would their explanation be? Why would, is it that they are not accepting the diminishing returns?
In their own mind, what the warmers model is based on is a little bit of global warming caused by carbon dioxide. That causes more water vapour to go into the atmosphere. That in turn is a greenhouse gas, and the system compounds away on itself. They basically believe that the Earth's climate system is very unstable, just about prone to have runaway. But it's actually very much a buffered system.
Hello, my name is Joe Kaufman. I'm Chief of Staff for Congressman Bridenstine. I worked in the energy industry for about 35 years and found that the energy industry sort of fell like dominoes as pressure increased from global warming alarmists, and we had major energy companies who basically came to the table and said, we've got to capitulate on this issue because of the pressures that are being placed upon us by NGOs and others. Do you perceive at this point that there is some reversal in that trend, not only among the energy companies, but perhaps among other corporate entities for whom this issue is an important one?
No, I don't. I also spent 30 years in energy, but most of the oil companies are pretty gutless.
Dan Byers with the Science Committee. I guess you talked at the beginning about attributing all the factors. Where do you see in the fact that the IPCC has sort of maybe painted itself into a corner in terms of attribution now that we've had the 16-year pause, and where do you see that heading, and what are they saying now in terms of some of these solar cycles or whatever else they sort of dismissed in the past as its relative contributions?
Well, they're going to ignore solar cycles for as long as they can. That's peer-reviewed literature I've referred to up there, and I don't expect it to be referred to in the IPCC report due out later this month at all. How the IPCC is going to die, I don't know. It'll eventually get defunded by the governments. This government throws in a good chunk of it, actually.
On the Arctic, the global warmers like to use the Arctic as their poster child, and of course this year we had a record gain, although it's not a record amount of ice, but it's a rapid. And the Antarctic they wanted to use, but of course that's been at or near record levels. So what is your prediction for Arctic sea ice and even Antarctic sea ice over the next 5, 10, 30 years? Did you model that or figure that into this? Did you figure that?
I don't model it, but if you go back and have a look at what happened in the 17th century when Iceland got cut off due to sea ice, and things like that, it'll be, but I'm concentrating more on the agricultural effect, real effects that are actually going to affect people. I'm sorry, I haven't got anything more to say on that, Mark.
A new challenge is something called climate sensitivity. If you teased out climate sensitivity, which is the change in temperature for doubling of CO2, I surmise that you would come up with a number of 0.
No, I come up with 0.4 degrees centigrade. That's what the ModTran model is telling me.
Okay. Is that equilibrium or transient?
Equilibrium.
Okay. 0.4. 0.4.
Yep.
Do we have that in a paper anywhere that we can use?
I think I published one about 6 years ago, coming up with that number.
We need to put that on the record today.
Yep. Anybody can replicate my work by going to ModTran, plugging in numbers. It's as easy as beak and pie to do that work that I've done.
That's the University of Chicago?
Yes.
ModTran?
ModTran. Now, by the way, this whole presentation's now available on my faculty page at the Institute of World Politics.
I'm Richard Yamada. I'm with the House Science Committee. Just had 2 questions, so 2-part. One is, it seems to me, I mean, I'm not an expert in this area, but it seems like with a lot of sciences where there's a lot of variables, you come down to this notion of correlation is causation science. So in other words, if I ate 10 blueberries today and I eat 10 blueberries 3 days from now, and both days they were raining, you would just say, well, if I eat blueberries, it starts to rain. So, you know, just want to ask if, you know, if that's, you see a lot of that in your field. And then the second question I want to ask, just curious from the, you know, some of the work that we've been doing with the committee is how reproducible are a lot of the results that, you know, are out there, and how widely available is that data?
Now, what I was very happy about was when the Norwegians replicated my work, because of the three authors of that report, one's a statistician, works for a Norwegian telephone company. So they made sure that their work was absolutely bulletproof. And that's their mid of their prediction, but that's the range. So it was all done properly. It's reproducible. If you've got 200 years of temperature data, you can do this stuff. Now, the relationships breaks down the further south you go away from the poles. So you don't see a relationship at Milan. There's a very weak one in Tunis, the capital of Tunisia. And the further you go inland into the Russian continent, the relationship breaks down and you can't see this solar cycle length temperature relationship. But for anything around the Atlantic basin, we get it. No one's done anything yet on China or Japan. Professor Solheim is now doing the Corn Belt, and it will be very interesting to see what he comes up with.
But my question is so much, if your work is reproducible, that's great, but I'm just saying, you know, if I remember correctly, wasn't there some scandal with East Anglia, you know?
Yep.
I think part of that, my understanding was they wouldn't release the data, or they wouldn't share it, or, you know, I just want to know how open, you know, if you put a theory out there, then your theory has to be,
Yep.
I mean, you know, that's part of the game, right? And you can't
Yep.
just start saying, well, I don't want to release this data, I don't want, and, you know, so it goes to their credibility, but, you know, I just want to ask in general, I mean, is most of this data, like, if you wanted to, you know, has someone gone out there, taken the 10 most important papers in climate science and tried to reproduce every figure, you
Well, it was Steve McIntyre who started that reproducing process about 7 or 8 years ago, and he basically found that what of the IPCC stuff was flawed, very flawed. That hasn't changed, in my opinion. If you talk about the real science that the likes of Solheim are doing, as I said, it's high school level stuff. I can do one of these records in about an hour flat with a template I've made up. But no one on the other side's ever going to touch this stuff, because by touching it, they're going to give it credibility.
It sounds from the leaks that are coming out that IPCC is going to make a number of concessions. There was a medieval warming period, for instance. There is a pause. What do you have any speculation as to what's happening? Are they actually beginning to confront contrary data here, or?
No, they're in denial. They'll be in denial for some time, right to the end, trying to put off the evil day that they're defunded.
David? Please join me in thanking David Archibald. David has made some bold predictions, just as the IPCC has made some bold predictions, and you're one man against the establishment, and it will be interesting to see who is closer to reality. It's a brave person who makes these kinds of bold predictions, but I hope this is demonstrated that there is a lot outside of the IPCC report that they really don't want to look at, and I think David has done outstanding work, whether his predictions turn out to be exactly correct or not.